December, week 1, math, 3rd grade, lesson 2, perimeter and area of rectangles. So they're going to be trying to trick you a little bit, you can tell. Meg has a garden. The perimeter of the garden is 12 meters. What's the perimeter?
12.
But what is a perimeter? Grayson. Ruben?
It's the area of length times width.
No, that's area. Silas.
It's the peri means
Around.
around and middle means measure. So sort of small shape.
Okay, it means all the way around. It means measure all the way around. That's perimeter. Everybody got it?
Yeah.
The area of the garden is 8 square meters. Meg drew diagrams of a garden with the same perimeter, but a different area. So, remember her perimeter was 12?
Yeah.
So she did 5 plus 5, that's 10, right? And 1 plus 1 is 2. But definitely the area is not the same. How much is the area of that one?
5
It's only 5. 5 times 1. Which garden's better?
maybe.
That one. This one has the same, you guys, the fence to put around this would cost the exact same as that one. But look how much bigger that is, okay? Then she drew another one. And this time she did 3, 3, 3, and 3. So let's count our 3s. 3, 6, 9, and 12. So is the perimeter still 12?
Yes.
Yes, it's 12, 12, and 12 on all of them. But what's the area of that one?
3 times 3.
Which is?
9.
So that's the best one of all. She gets 9 square meters out of that one, okay? All right, perimeter, 5 plus 1 plus 5 plus 1, 12. Area, 5 times 1, 5. Then she drew another diagram of a garden with the same area, but with a different perimeter. Remember her first area was 8, right? 4 times 2? Okay, look at this one. She's doing 8 times
1.
1, which is still going to have an area of 8. But the perimeter, down at the bottom it says, is 1 plus 8 plus 1 plus 8, which is 18. Is this a good garden?
Yes. No.
No, that's going to be a very expensive fence. 18 is a lot more than 12, and the area is the same as that one. So the best one is probably that square one. Perimeter, 3 plus 3 plus 3 plus 3 is 12. Area, 3 times 3, 9.
So it's only 9.
All right, that's the best one.
If I was just going to say that one.
Example 1. The rectangle has a perimeter of 24 feet. That perimeter means, guys, all the way around, right? Peri means around. Meter means measure. Perimeter. Draw another rectangle with the same perimeter, but use different side lengths. They're giving you a strategy. Change the length and then adjust the width so that you can create a figure with the same perimeter. First of all, remember what the perimeter is? 24, right? 8 plus 8 is 16, plus 4 is 20, plus 4 more is 24. So strategy step 1, change the length. The length of the rectangle is 8 feet. Change it to another number. The number 10 is an easy number to add mentally, so use 10 for the length. So they're drawing it with 10 and 10, okay? The perimeter is 10 feet plus something feet plus 10 feet plus something feet. Do you see the little question marks? Which is 20 feet plus something feet, right? Because 2 tens is 20. Use the perimeter to find the unknown. You want the perimeter to be 24 feet. 24 is 20 plus something. 24 is 20 plus 4. The unknown is 4 feet. That is the total measurement of 2 sides of the rectangle, not 1. Remember, 4 feet for both. So Gideon is correct. The width has to be 2 because you have to divide by 2 to find the width because there's 2 sides. 4 divided by 2 is 2. So the width is 2. Everybody got it? Okay. Example 2. These two rectangles have a perimeter of 24 feet. How do their areas compare? Rectangle A and rectangle B. Rectangle A is the one that had 8 plus 8, which is 16, and 4 and 4 is 8, 16 plus 8 is 24. Rectangle B is the one with 10 plus 10, which made 20, and then 2 plus 2 made 4. Okay, strategy. We're going to multiply to find the area. Find the area of each rectangle. Rectangle A is 8 times 4, right? Length times width. 8 times 4, which is 32. Rectangle B, 10 times 2, which is 20. So the area of A is 32 and the area of B is 20 square feet. Flip that sheet over. Compare the areas. 32 square feet is greater than 20 square feet. Rectangle A has a greater area than rectangle B. The rectangles have the same perimeter, but they do not have the same area. Solution. The area of rectangle A is greater than the area of rectangle B. Example 3. Ida drew this rectangle in her painting. The area of the rectangle is 40 square inches because it's 8 times
5.
5. 8 times
5.
5. Draw a different rectangle with the same area but a different perimeter. Strategy. Think of other. I want you to circle this word. Factors with a product of 40. So we can't do 8 times 5, guys. We have to think of some other factors that are going to give us 40. The area has to be 40 square, excuse me, I'm reading. The area has to be 40 square inches, so the product of the length and the width must be 40. What other factors have a product of 40? 4 times 10 makes 40. So the length could be 10 inches and the width could be 4 inches. Draw and label a rectangle with the new measurements. 10, 10, 4, 4. 10 times 4 is definitely going to give us 40. Flip your whole packet over. Excuse me, they already did 5 times 8, Gage. Are you all on page 308? Find the perimeter of the rectangle Ida drew. The perimeter of 8 plus 5 plus 8 plus 5 is 26 because 8 plus 8 is 16 and 5 plus 5 is 10. What is 16 plus 10? 26. Okay. Find the perimeter of the new one. The perimeter is 10 plus 4 plus 10 plus 4. 10 plus 10 is
14.
10 plus 10 is 20. 4 plus 4 is 8. So her new one is 28. Solution. A rectangle with the same area but different perimeter is shown in step 2, and it has the length of 10 inches and width of 4 inches. Coached example. This is where we're finally going to get to do some stuff ourselves. The rectangle below shows a poster Nathan bought. It has a perimeter of 10 feet. Look, guys. What's 3 plus 3?
6.
And 2 plus 2?
4.
And 6 plus 4 is 10. So it has a perimeter of 10 feet all the way around. Draw a rectangle that has the same perimeter but a different area. The perimeter must be something feet. Thank you, Ruben. It said it has to be the same, right? So it must be 10 because Nathan's is 10. Thank you. Change one of the side lengths from Nathan's poster. Make the length 4 feet. All right. Write the new perimeter equation with the new length. 10 is 4 plus question mark plus 4 again plus question mark, right? It's got to have two sides that are 4. So you should have written 4 twice. Find the unknown. 10 is, well, what's 4 plus 4? 8 plus something. 2. Question mark must be 2. The unknown is, you just said it, it's 2. That is the total measurement of 2 sides of the rectangle. We've got 2 short sides. Together they make 2. Now take your sheet and turn your sheet over, not your whole packet, just the sheet, to get to page 309. So divide by 2 to find the width. 2 divided by 2 is
4. 1.
1. 2 divided, look, here's 2. Divided into 2 groups, and there's 1 in each group.
1.
2 divided by 2 is 1. So the width is 1 foot. Draw the new rectangle and label the measurements. Okay, they said 4 and 4 for the length, right? So make 2 sides be 4. And then we're going to do these little guys, 1 each. And we can add it and see if it comes to 10. 4 plus 1 is 5. 4 plus 1 is 5. 5 plus 5.
Yep. 10.
All right. Find the area of Nathan's poster. Okay, not the area of the new one, guys. The area of the one he drew before. Do you guys remember its measurements?
Let's go back to the.
You can go back and look. You can cheat and kind of look. It was 3 and 2. So area is length times width. So we're going to do 3 times 2.
Was 6.
Which is 6. Good. I'm waiting for Gage. Okay. So the area of Nathan's poster is 6 square feet. Find the area of the new rectangle. Area is length times width, guys. Look up here. What are we going to put?
4
Times 1.
4 times 1 equals.
And that's 4. 4 times 1 is 4.
Anything times 1 is
The area of the new rectangle is 4 square feet. The new rectangle has a length of 4 feet and a width of 1. It has a perimeter of 10, good, and an area of, no, only
6. 4.
4. Now the new one is 4. The old one, the one he drew first was 6, right, Ruben? Which one would be a better one? The one that had a bigger area, yeah, because the poster would be bigger, right? Even though the perimeter is the same.
Probably more expensive though.
Possibly, yes, because it uses more paper. Please flip your whole packet over like this, and you'll be on page 310. Draw a line from each rectangle to the rectangle with the same area. Ooh, this is probably one of the hardest things we've done yet. So, who wants to do A? Grayson. What's 6 times 4?
It is
Count your fours.
4, 6, 12, 16, 20, 24, 28.
24. Okay, so this guy's 24. You can write that in there if you want. Grayson, would it match this one across from it? 6 times 6?
No.
No, that's 6. 6 is a thirsty. 6 times 6 is 36. So it's not that one. How about this one, Grayson? 4 fives. Count your fives.
5, 10,
5, 10, 15, 20. Can you go do that somewhere else? Thanks. 20. So it's not that one. Okay, try this one.
No.
2 times 9?
No.
9, 18. No. Try this one.
Then, yes.
Well, skip count your 8s and make sure.
3, 6, 9, wait, 8, 16, 24.
Aha. You found it. This one is 24. So the A goes all the way to that bottom one. Who would like to try B? Silas.
4 times 9.
9,
8,
27, 36. Do you remember which one over here was 36? Aha, you found it right away. 6 times 6 is 36. Okay, who would like to do C? Gideon.
3, 3 times 6. 3, or 6 times.
You can do either. 3 times 6 or 6 times 3, whichever you prefer. Ooh, no. Excuse me, you're not doing this one. Say the, skip count your 6s. 6,
12, 18.
18. Okay.
I remember which one was 18.
Gideon, do you remember which one was 18? Yeah, 9 times 2, right? 2, 4, 6, 8, 10, 12, 14, 16,
7 has to be the other ones.
Hey, Ruben, don't interrupt, honey. And yeah, 2 times 10 is 20, and 4 times 5 is 20. Okay. Tough stuff, huh? You guys did pretty good. Now you're going to flip just this page, not the whole packet, just this page to get to 311, page 311. Draw 4 different rectangles that have a perimeter of 16 units and use only whole number units for length and width. Okay, does anyone want to do one of them? Okay, Silas. Sweetie, we're not on that. We're on this part. Draw 4 different rectangles that have a perimeter of 16 units. Gauge. Okay. You guys, what does perimeter mean? Grayson, what does perimeter mean?
The first poli means round,
Good.
and meter means measure.
So all the way around has to be 16. So who wants to try and make one? Oh, Gideon.
Okay.
Nope, that's not going to work. If you make one side be 16 and another side be 16, that's already going to be 32. We want the whole way around to be 16. Do you guys want me to do the first one just to get started?
Yeah.
Okay. I think I'm going to do 5 plus 5 to make 10 and then 3 plus 3 to make 6. Is that all right with you guys?
Yeah.
All right, so we're going to do 1, 2, 3, 4, 5. And then down 3. 1, 2, 3. And then 1, 2, 3, 4, 5. And then 3 again. So 5 plus 5 is 10, and 3 plus 3 is 6. Does that get us to 16? Yes. Okay, Grayson, you want to?
8 and 2.
8 plus 8 is 16, and then 2 plus 2 is 4, so that would get us to 20. All right.
6 and 6 is 12, and 2 and 2 is.
All right. So he's saying let's do 6 and 6. So ready, guys? You're going to go 1, 2, 3, 4, 5, 6. And then he said go down 2.
Yeah.
And then go back 6. And up 2. Now, is he right? 6 plus 6 is 12.
Yes.
And 2 plus 2 is 4. Does
Yes.
that get us to 16?
Yes.
Yes. Good.
What about
No, it doesn't. It gets us to 60.
15?
All right. Who wants to try a different one?
Wait, but the 5 times 3, it gets us to 15. There's 15.
But they didn't ask for area. They asked for perimeter
Oh.
of 16. So be real careful. See, I told you this packet was going to be tricky, Ruben. It's tricky, huh? It's very tricky. It's a tricky little packet. Silas. I'll let you do next. Okay, let's do Silas.
8 times 2.
Ooh, no. You see, if we do 8 plus 8, that's already 16. And then 2 plus 2 is 4 more. So that's too big.
6 across, 8 across, and 2 down.
Nope.
It equals 16.
No, it won't. That's the area. You're making the same mistake as Ruben. They want the perimeter to be 16. So if we did 8 and 8, that's already 16. Right? For the long sides. And then the 2 plus 2 would make 4 more, which is 20. So that's too big.
Can I?
Ruben.
4 down
Ruben got one.
and 4 across.
Yes. So if we do 4 plus 4, that's 8. And 4 plus 4 again, that's 8 more. So that is 16. All right. You got one. So we're going to go 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And 1, 2, 3, 4. Yeah. Is a square a kind of rectangle? Yes, it is, because rect means right. A square has 4 right angles, which makes it a kind of rectangle. Okay, so look at this, guys. 4 plus 4 is 8, plus 4 more is 12, plus 4 more is 16. All right, who wants to have a go at the last way? Gideon. No, that's going to be way
14 across.
Wow.
Well,
No, because 12 plus 12 is 24. Isn't this horrible?
12, 12,
Grayson.
1, 1.
No, that's 24 plus 2, which is 26. Grayson. It is something plus 1, though. The 1 and the 1, that's correct.
6 plus 1.
Ooh, you're close.
7 plus 1.
Yes. Okay, guys, the last way. Ready? We're going to go. 1, 2, 3, 4, 5, 6, 7. 1. Gideon, sit up. Now go 7 up. 1, 2, 3, 4, 5, 6, 7. And 1. And now if you add it up, 7 plus 7 makes 14. And 1 plus 1 makes 2. Is 14 plus 2 going to give us a perimeter of 16? Yes. What are the dimensions of the rectangle with the greatest area? Well, which one has the biggest area, guys? Definitely Rubens 4 and 4, right? The dimensions of the rectangle with the greatest area are 4 times 4. Length and width are both 4. The dimensions means length and width. What are the dimensions of the rectangle with the least area?
7.
The 7 and 1. Yeah. That one's tiny. Rubens uses the same amount of material as that one, but we have an area of 16. This one uses the same amount of stuff, but you only get an area of 7. What a huge difference. Miguel drew a square that measures 6 inches on each side. Select true or false for each statement. You guys ready? A rectangle that measures 12 inches by 2 inches has the same area as his square?
False.
False. Good. What? By the way, you guys, what is the area of Miguel's square?
6. Like 6.
What is the area? Length times width, guys.
Okay. 2.
Oh boy. Everybody sit up. Okay. You guys are starting to get tired. Miguel drew a square that measures 6 inches on each side. I'm just going to draw it.
Oh, 36.
What's its area? Length times width. 6 times 6. Good. Okay, so a rectangle that is 12 inches by 2 inches has the same area. What is 12 times 2? Sit up. 24. So that is false. B. A rectangle that measures 10 inches by 2 inches has the same perimeter. Square. Okay, don't say a word. Don't you guys say a word. We need to find out the perimeter of his square. We have only found out the area. So, we're going to go all the way around his square. 6 plus 6 is what?
12.
Plus another 6 and another 6. 12 plus 12.
24.
Now let's think about this one they're talking about. 10 and 2. Ready, guys? What would the perimeter be? We got 10 here, and 10 here, and 2 and 2. What's 10 plus 10?
20.
What's 2 plus 2?
4. 24. True.
So it's true. This one has a perimeter all the way around of 24, and his has a perimeter of 24. It's true. Is this our toughest packet we've ever done?
Yes. No.
C. There are no other squares with the same area as Miguel's square.
False.
True. There are other rectangles that could get you to 36. 9 times 4 gets you to 36, right? 9, 18, 24, 9, 18, 27, 36. But is that a square?
No.
Is 9 times 4 a square? No. There are no other squares with that same area. The only square that gives you 36 is 6 times 6. So that is false. Sorry, that's true. D. There are no other rectangles with the same area as Miguel's square.
False.
False, because do 4 times 9, guys. 9, 18, 27, 36. That's going to give you the same. So that one's false. What about 36 times 1? Would that give you an area of 36?
Yes.
Sure. What about 13 times, wait, what about, not 13 times 2, 18 times 2. That's going to give you 36. So there's quite a few other rectangles that will get you to 36, but no other squares. Flip your whole packet over. Zan is making patches for a quilt. She wants each patch to have an area of 36 square inches. Draw and label 2 rectangles that have an area of 36 square inches. Okay, one of them is right there. Should we do that? Okay, let's do it. Because a square is a kind of rectangle, so we are allowed to do it. Well, can anyone come up with another one? What else? What are some other factors that get us to 36? Because this one, no, that's 12.
6 times 4.
That's 24. We're trying to get to 36. Well, that's the one we just did. It is something times 4, Gideon.
9 times 12.
9 times 4. Count your 4s. 4, 8, 12, 16, 20, 24, 28, 32, 36. Ta-da! So that's two different ways to get the patches to have the area that she wants.
Is there any else?
Part B, describe how you found the measurements of the rectangles that you drew. Oh boy, this is easy. What was the first one?
I looked at my
6 times 6 is 36. And the second one?
I looked at my thing.
What's the equation for the second one?
9 times 4.
9 times 4 is 36. And you're scooping up an awful lot of points when you do this. And it's not that hard, is it?
Yep.
Scooping up points. Number 5. Gideon, hurry up and get caught up. Put a 4 there. A 4 there by that side. Good. Now write 6 times 6 is 36 and 9 times 4 is 36. Good. And now 9 times 4 is 36. Number 5. Joe drew a square. He says that there are many squares with the same area as his square. Beth says there are no other squares with the same area as Joe's square. Who is correct? Yes. Why? Yeah, one square cannot have the same area as a different square, right? Because the sides are all the same. Okay. So you can write one square
But it says draw and explain to prove
cannot equal a, well, you can draw a square instead of writing square then. A different square because the sides are all the same. Exclamation mark. Please feel free to draw a square instead of writing the word square if you want, because Reuben is correct. They did say you could. And then it says, draw an example to prove your reasoning. This is going to be super fun. Let's draw a square where all the sides are 1, and then a square where all the sides are 2, and just put a they are not equal sign between them. So here's my square with 1s. And then here is my they are not equal sign. And then here's my square with 2s. And if you want, you can change those and make it 100. Okay? But
I'm just gonna draw like a square and put like an arrow kind of like on the side for sides.
I just did this.
super cool. I believe we are done. Oh, we have one more side. All righty. Let's do this. You can go back and finish. Number 6. Sophie drew a rectangle. It has a perimeter, not area, perimeter of 18 inches. Its area is 18 square inches. What are the length and Okay, guys. The most efficient way to do this is to think of all the factors of 18 and find those first. Factors of 18, guys. 6 and 3. Okay.
4,
No, 4, 8, 12,
Two.
16, 20. That one will 2 and 9, right? And I think that's
6.
it. We did 6 and 3 and 2 and 9. Done.
3 and 3.
Nope, 3 times 3 gives us 9.
I mean 3 times
3 times 6. We got it. We
2
got it.
times 1. Is that it? 2.
Well, now we have to decide which of those will give us a perimeter of 18. Only one of them will. So Gideon thinks it's the 9 and 2. So if we do 9 plus 9
I think it's
plus 2 plus 2, 9 plus 9 is 18, 2 plus 2 is 4. Uh-oh, the perimeter is 22. The 6 and the 3, okay. 6 plus 6 and 3 plus 3. 6 plus 6 is 12. 3 plus 3 is 6. What's 12 plus 6?
18.
18. It's got to be that one. All right, so we're going to cross the other one out. Length must be, longer side must be 6. Width must be 3. What? Gauge. Number 7. Chang is making a playpen for his puppy. It will be the shape of a rectangle. He has 20 feet of fence. Part A. What are some of the measurements of the pen Chang could make? So he has to get to 20. The perimeter has to be 20. How can he get there? 4. Ooh, 4 plus 10 would give us 14. And then 4 plus 10 again would give us 14, which is 28. That's too big.
4 something something.
Ooh, you're way closer now.
4 and 5. 4 and 7.
Whoa, whoa. Stop yelling out. Let's go back to gauges 4 and 8. If we did 8 plus 8 for the long sides, that's 16. And then 4 plus 4 is 8. Ooh, we're still a little too big.
5
That's
and
24.
2. 4 and 6.
Ooh, 4 and 6. 6 plus 6 is 12. And 4 plus 4 is 8. Does 12 plus 8 get us to 20?
Yes.
Yes.
I tried. No.
What's one more way that he could get to 20? Grayson.
5, 5, 5, 5.
Yes, he could do all 4 sides the same, right? Make a square and make them each 5. Because 5, 10, 15, 20. Let's do that one. Part B. Which pen would give the puppy the greatest area to run around in?
6 and 4.
All right. Before you yell it out, we got to figure out the area. Let's do this 4 and 6 one first, because that's what Silas thought of. Silas, skip count your 6s to 4 of them. Ready?
6, 12, 18, 20.
Okay. 24. I'm going to make that darker. Grayson, figure out the area of yours.
5, 10, 15, 20, 25. The area.
Grayson's is bigger.
Yeah, but mine has a more good thing to say.
So which pen will give the puppy the greatest area? The 5 times 5 one. Number 8. Hilda wants a garden to have an area of 20 square feet. She'll put a fence around the garden. What is the least amount of fencing she could use? Explain your answer using words, numbers, or drawings.
21. No, I don't know.
I love the idea of doing drawings.
Yes.
Okay, so what's one way she can do
6.
this?
6 and 2.
She wants it to. Oh, okay. You're all forgetting something.
12 and 12.
You're all forgetting something. They didn't tell you perimeter this time. They flipped it to area. I just put yellow on area. So we need factors of 20. What can get us to 20? 2 with what, Gideon?
Well, 5 fours.
5 fours can get us to 20. Okay, so 5 and 4 are factors. So let's draw that one. This will get us to 20. Grayson said 5 times 4. Well, that's... Okay, what else can get us to 20? Yes! 10 times what?
2.
Yes. It's a totally different looking rectangle, right? 10 times 2 gets us to 20. And that's it. There are no other factors of 20. 5 and 4 and 10 times 2. Which of them gives us less fencing? They both get us to 20 for the area, but which of them uses less fencing?
5 and 4.
Definitely. What's 5 plus 5?
Is 10.
And 4 plus 4?
8.
8. So this one, the perimeter is only 18. What's 10 plus 10?
20.
And then 2 plus 2? 4. So this one, the perimeter is 24. They both have an area of 20, but that one uses a lot less fencing. So we're going to explain, we're going to put 5 times 4 uses least because 5 plus 5 plus 4 plus 4 equals 18. Yes, you do, because they want you to prove it. But 10 plus 10 plus 2 plus 2 makes 24. Okay? Lots of writing. You would get a humongous amount of points for that. Because you used factors, you used diagrams, you used words, and you proved it. You used equations. You're using every kind of math, okay? Only like super uber geniuses can even do that. Points would be like if you were in a competition, like math counts, and they asked you a question like this, your team would probably win if you got this one. Okay? You would
But how
probably
many
win.
points would you get?
Oh, like 100, I guess. Like it would be worth a huge amount of points. And does our school compete in math counts? Yes, we do. Yeah, sure we do. Yep. So usually points are in competitions. Did you know that some of the greatest discoveries have been made because of competitions? Now, other ones have been made just by observing nature. The guy that invented Velcro, he did that by observing those little seeds that stick to you. You know, like prickly burrs.
Oh, yes.
And he created that same stickiness with tiny barbs on the end using Velcro. And he made a lot of money doing that. Velcro's cool stuff, okay? We all use it. But the guy that invented the steam engine, which is, we have cars because of that, he did that because of competition. It was in England, which is where I grew up. In England, they were mining coal, and every time they got 30 feet down, it would flood, because England is close to sea level. It's not high up like Colorado. So it doesn't happen here. Like, you can mine coal and go a whole mile here, and you're not going to hit water, okay? But in England, you go 30 feet, you're going to hit water. So they kept flooding, and they were like, we need coal. So the government said, we're going to do a competition, and anybody that can invent something to get the water out gets to win, like, I think it was like 100,000 pounds, which back then that was millions of dollars, okay? The guy invented the steam engine, a steam pump to get the water out, and then they turned it into an engine, and then they started making trains that use them, and then they made cars that use them, and that's how we have all our modern transportation. And he did all of that because of a competition.